So welcome to the first River Basin Management Society webinar for 2020. We will be talking about bushfires and waterways today and the impacts on water quality and yield in forested catchments. There we go. So your host today is myself, with support from Jess Walker, our Vice President, and Genevieve Smith, our Technical Lead, and our broader committee team. If you'd like to find out a bit more about the committee, you can head to our website on www.rbms.com.au. So I'd like to begin today just with our acknowledgement of country. We acknowledge the Aboriginal and Torres Strait Islander people as the first peoples and original custodians of Australia's lands and waters and honour their elders past, present and emerging. We acknowledge and respect the continuing deep spiritual connection that Aboriginal and Torres Strait Islander people have to country and their unique ability to care for country. So who we are. River Basin Management Society, a diverse community of practice in Australia. So for those of you who are not members joining us today, we're dedicated to connecting people and sharing knowledge in integrated catchment management. We're driven by our members and we're supported by an elected volunteer committee. So we invite new members to join us in integrating catchment management for Australia. And as I said before, you can have a look on our website to get more details. Today's guest speakers that we have lined up, we'll first be hearing a presentation from Dr. Peter Nyman on bushfires, erosion and risk to water quality. From that, we'll then also hear from Phillip Jordan about bushfire impacts on water yield from Victorian catchments, and Rachael Brownstein, the response of the East Gippsland Water to ensuring drinking water supply to local townships during and post bushfire events. So just a little bit about our first speaker, Dr. Peter Nyman. So he is a hydrologist at Alluvium with research at the University of Melbourne part-time. He is specialising in water and sediment dynamics in forest catchments with research in erosion, eco-hydrology and wildfire, and uses his results to develop risk models and decision support tools. So I will just quickly let you know some other features for today's presentations as well. We'd like to ask all people attending to please submit any questions in the Q&A feature at the bottom of the screen instead of using the chat or raising the hand function. That'll give us opportunities for other people joining us to upvote questions that you all want to be able to have responded to. We'll have 5 minutes after each presentation to respond to the questions. And for those that aren't answered during the session, we are going to keep a record of the questions. We'll follow up with responses from our presenters, and we will include it in a post-event follow-up with hopefully a recording of this session to give to all attendees. So with that, I will pass over to Dr. Peter Nyman.
Share my screen. Does that screen show up okay, Janice?
Yes, but we're seeing it. I'm seated in presenter mode.
How is that?
That's better, Peter.
Thanks for the introduction, Janice, and thanks for the opportunity to present to the RBMS today. my talk is on post-fire erosion and implications for water quality, and this is very much a collaborative effort. So this is work that I've been doing with my colleagues at University of Melbourne, Gary Sheridan, Patrick Lane, and Ian Rutherford, and also with Peter Yeats at Hydronumerics and Shane Hayden at Melbourne Water. Just a quick outline of the talk. So first I'll be just covering some basics around post-fire erosion processes and the hydroclimatic context around some of the events that we've seen in Southeast Australia over the last decade or so. And then from that, we'll talk about how models can inform catchment management, and using 2 case studies to illustrate how we've used our research and our research utilization to help guide risk assessments and catchment planning. So a lot of the work that we've been doing has been focusing on extreme erosion events. So we find that debris flows, so post-fire debris flows in particular, are the ones that show up in records of events that have large impacts on water quality, whether it being on ecological assets, reservoirs, and sort of direct threats to infrastructure. These large events that happen relatively infrequently, but triggered by intense rainfall, are the ones that really focus on in our modeling and our research. And debris flows sort of stem from a cascade of processes where you begin with I'm gonna just get my pointer here, with this direct impact on the soil, where heating of the soil results in water repellency, low infiltration rates. That triggers surface runoff. So a lot of surface runoffs get produced when you have rainfall. The surface material gets stripped off, so a lot of ash and gravel and soil washes off the hill slopes, gets delivered into converging headwater catchments, where you get gullies being triggered, so channel incision, lots of sediment being generated, turning into debris flow slurries, which then delivers sediment into streams and reservoirs. So this process is really what a lot of our work is focusing on. And we find that since these large regional wildfires since 2003 and in 2007, 09, 13, this sort of scenario has been a reoccurring theme. Lots of fine sediment and turbid water with quite significant impacts on the different values for which these systems are and waterways are being managed for. And I guess more recently in just the last few months, we've seen again examples of these sorts of events. On the left here you have the Cotter River catchments in ACT, quite a lot of rainfall after the Orwell Valley fire up there, and lots of turbid water being delivered into the Corian Dam and the Bendora Dam, which forms part of the water supply catchments to ACT. And on the right here is the Tambo River after significant rainfall up there, and a huge buildup of woody debris behind a river crossing here in the Tambo River itself. And I'll show some video footage of that event in a little while. Right here, actually. This is footage captured from DELP staff who are out doing some fire recon work. And this is on the, the Alpine Road from Bairnsdale up towards Omeo. And this is a gully crossing the road, and not a huge rainfall event. I think sort of 20 to 30 millimeters per hour intensity over half an hour. And this is the sort of scenarios that we've seen on several occasions following these large bushfire events. And this is looking down into Tambo River itself. Quite a substantial geomorphic event with all sorts of implications for downstream water quality. And I guess what we can see is the sediment, but of course there's a lot of material being carried with this sediment. So there's a lot of organic material, a lot of nutrients associated with the ash. So often with these events, we see elevated phosphorus concentrations, elevated nutrient concentrations. And another sort of bit of footage to help illustrate what we're dealing with. This is from the Aberfeldy fire in 2015. And I guess it all starts on the hill slope. And this is where all that water is being generated, and also where a lot of the sediment is being generated that actually kicks this process off. It's sort of a cascade of processes. So you start off with just a few sort of rills forming, and then as you move down the hill slope, those rills grow and they get more and more stream power and start to push a lot of the ash and sediment down the slope. So here I was fortunate to witness a little bit of this process starting to kick off. The rainfall event wasn't sufficient to really get this debris flow going, but it really gives you some insights into how this process is triggered and the importance of hill slope controls on, this is where I left the catchment. And so what we've seen over the last decade or so is quite a large number of these events throughout the southeast region of Australia. And it's happened in response to quite extraordinary hydroclimatic conditions. So droughts through the sort of first part of this millennium, so 2000, 2009, the millennium drought, and then following that there was the drought-breaking rainfall in 2010 and 2012. And both of these events, looking back over quite long time frames, are unprecedented, both in terms of extent and severity. And we've seen quite a lot of debris flow activity across this region in response to these hydroclimatic events. And see sort of two types of events, two types of debris flows. There's these that are fire related and some that are flood related. And so we see these periods of fire related debris flows and periods of flood related debris flows. And these are linked to significant rainfall events, which kick off in the later period of this record, and large areas of large burnt areas, which sort of were more dominant at the beginning of this record. And when we look at soil moisture modeling and the ENSO signal, we see some correspondence there with these regional hydroclimatic drivers that drive these type of erosion processes. So there's some indications that this problem isn't going to go away. The future suggests stronger ENSO cycles, so stronger and more frequent El Nino and La Niñas, so more drought and more rainfall, increase in rainfall intensities as the temperatures rise, and also more fire as we see more extreme fire weather into the future. So the problem isn't going to go away, and we see probably this sort of scenario where you have streams that are deprived of sediment or transport supply limited in terms of the sediment regime, moving to this sort of scenario where you have a lot of sediment available for transport. So what can we do about it? Well, one of the first things is to use fundamental research to inform model development. So we have spent a lot of time in the field through my work with Melbourne Uni and Melbourne Water, measuring stuff, measuring runoff rates, measuring infiltration rates, surveying catchments, measuring runoff from small headwater catchments. And I guess in one we've been blessed with a lot of burnt areas to work in. And through that, developed a lot of fundamental science that we can build on to help inform management and develop models. And models are important because they help us understand where in the landscape threats are concentrated, the magnitude of the threat, and how threat translates to risk. And they also help us understand opportunities for mitigating risk. Type of models that we use depend on our management setting. So we can go from quite sort of coarse management questions around just identifying risk factors through to really quantitative risk assessments in water supply catchments, for example. But our management setting also has different requirements in terms of knowledge and data availability that we need to inform the models that we use to solve management problems. So if we don't have a lot of knowledge, we're sitting up in this region using just geomorphic principles, and we move down to a situation where we have a lot of data where we can develop site-specific bespoke models for particular management questions. So we really need to ensure that our management questions and our knowledge and data availability are aligned. And the two case studies that I'm presenting today sit in two sort of different domains, if you like, in relation to these two gradients of management setting and data availability. And the first case study is about managing post-fire erosion risk in the Upper Yarra catchment. And what we're going to do here is just go through a process where we've developed a model to really understand the probability of a consequence, where what's the probability of the water supply going offline. And to do that, we'd first develop an erosion model where we try to understand the annual exceedance probability for mass of sediment delivered to the reservoir. We couple that with a reservoir hydrodynamics model, which enables us to model how many days of untreatable water will you have at the offtake for a given mass of sediment delivered to the reservoir. That in turn gives us a basis for predicting the annual exceedance probability for days of untreatable water. So really we're getting to that really core element of risk, which is the probability of a consequence. What does that look like in practice? We have a catchment erosion response model. These are erosion thresholds for debris flow generation. We link that to reservoir hydrodynamics. So this takes a plume of sediment and propagates it through the reservoir towards the offtake. And then we get these risk profiles, which is essentially showing us how many days of untreatable water are you likely to get for a given rainfall event. And the way you would read this is say, okay, for an event with an annual exceedance probability of 35%, you have a clay input of about 3,000 tons, and that translates to about 200 days above treatment threshold. So these are substantial risks to Melbourne water. So 200 days of untreatable water, there's a 35% chance of that happening in the case of a Black Saturday type wildfire scenario in the catchment. So we presented this to Melbourne Water and tried to understand, okay, what are the opportunities to mitigate risk and reduce these risk profiles so that the cost to Melbourne Water is less. So we run a number of workshops with both operational and strategic staff within Melbourne Water to try and understand what are the criteria that we need to consider when looking at mitigation opportunities. And some of the key ones were, safety to personnel. These are dangerous environments, so you don't want to have field crew out there working in hazardous environment, implementing a bunch of strategies where they put their own lives at risk. Access, you can only put stuff in when you have access. Maintenance or cost, and then legislative and statutory. So these are national parks lands, so any mitigation measures needs to be cognizant of the impact that you have on the catchments beyond just the immediate mitigation associated with these post-fire erosion events. So we arrived at a list of possible solutions. So core logs on the hill slopes, some debris barriers up in the headwater gullies to stop large sediments from kicking off this debris flow process, debris racks and road embankments to create a bit of an impoundment to stop that or attenuate at least the amount of sediment that's moving downstream. And further downstream, also work with these existing road infrastructure to help, again, create impoundments to stop or at least reduce the amount of sediment and debris that's moving down through the system. And so how do the risk profiles respond to these type of interventions? We can model that, albeit with a lot of uncertainty. I haven't shown the uncertainty here, but it's a first crack at trying to understand how and the effectiveness of these intervention strategies. And so this is, the brown line is the reduced risk profile as a result of core logs distributed on hill slopes that are accessible. Core logs with sediment barriers up in these headwater gullies. And then core logs, sediment barriers, and check dams. And you sort of end up with this progressive reduction in the risk profile, and where risk is about the days above the treatment thresholds at the offtake. And we can present that as residual risk, where you have the level of risk relative to your baseline for the different interventions that we've considered, where one is business as usual, and then the reduction in risk for these different treatment options or mitigation options. And this is some information that Melbourne Water can use directly to help understand cost and benefits of intervention. What would this look like in practice? This is a drawing we made up with the help of a graphic designer. Quite major catchment interventions, lots of works. This is big decisions. If this is something you want to pursue, it's going to be costly. You're putting potentially people's lives at risk, and you're going to deal with maintenance issues in pulling this stuff out and emptying the basins from sediment. So that's the case study number one. Case study number two is sort of this much more regional assessment of erosion risk. When you're faced with a fire, what is the risk across the landscape of erosion? And here we don't have the same information that we do for this specific Upper Yarra catchment. So we worked with a revised USLE model to map erosion risk using the best available science that we have to modify vegetation and soil properties within this modeling framework to get maps of erosion risk. This is something we produced within 1 month of the fire having, or actually still while the fires were burning. So we can very quickly provide information about erosion risk. While the numbers might not be perfect, but at least it's internally consistent, and it is consistent with existing modeling frameworks. And we can present this data in terms of absolute numbers, but also factor increase relative to background values. And we really want to build on this as a framework for quickly getting in and understanding what the risk is to our waterways. And this only really deals with the hill slope erosion part. So how can we expand on this to actually link it to risk in waterways? Well, first we have sediment delivery from hill slopes. Then we have to link that with river sediment transport model. So hill slope channel coupling and river sediment transport modeling. Then we want to understand what that means for the sediment regime in rivers. And actually that is our measure of threat. And then overlay that with the assets that we know are vulnerable to this change in sediment regime. These might be ecosystems, species, galaxids or Macquarie perch, or it might be reservoirs. And so that really is about understanding the consequence. And together, all these information provides a basis for quantifying risk. And this can be done quite rapidly if we have the right tools. And this is not about doing a lot more research, it's more about using existing tools and consolidating knowledge into a framework that can be used to assess risk. And I think this brings me to my conclusion that there's already quite a strong knowledge base out there on fire and sediment generation. Large gaps still remaining, especially with respect to how this plays out in different geographic settings, and also how sediment and nutrients and sort of those other elements of water quality that I haven't talked about here. And I guess in the future, really make sure that our modeling priorities and research efforts are really underpinned by robust and guided by robust risk frameworks, because that's really what should dictate where we spend our money in research and model development. And these sorts of bow and tie diagrams are an example of a risk framework that we can use to help guide such efforts. That's it from me. Thank you, Janice.
Check I'm unmuted. Thank you so much for that, Peter. That was a really great presentation, and we had some pretty quick questions come up almost as you started speaking. So what we'll do is we'll go have a look what we've got here. So we have, where did it go? So one of our first questions was, what is the mechanism resulting in hydrophobicity in the soil post-heat fire?
Essentially, it's the organic substances that sit within the top soil and in the litter layer. They burn and they create vapors. And as those vapors get pushed into the soil, they condense on the soil particles when they cool. And those vapors are hydrophobic. So they're highly, organic compounds that repel water. So it's really about those compounds being released during heating and then condensing on the soil particles.
Okay. We'll just move to the next one. So there've been a few upvotes. So we have one from Ian Rutherford, who was had to leave a moment ago, but I assume he may come back. And all our answers will be sent through to the participants after this as well. So he asked, could you comment on whether these debris flow might be a finite process? That is, they occur once under the mechanisms you describe, but then the valley floor will fill so slowly with sediment that they won't happen again for perhaps centuries.
Yes, I mean, that's a really interesting question, because it is the infilling of these valley floors is a slow process, and we're doing some work to try and quantify the rate at which these valley floors are filling in, so using radiocarbon dates. And once you have a debris flow event, it evacuates a lot of that sediment. So whilst the conditions for the triggering conditions might ramp up, both in terms of the frequency of wildfire and the intensity of rainfall event, the sediment might not be there to actually produce this type of response. And especially in Southeast Australia, which is tectonically fairly inactive, it means that the sediment that's being produced it's very slow. It's a slow process, and very different to, for example, the Western US. These gullies get recharged really quickly due to tectonic uplift and really steep slopes and dry ravel. Within years, the gullies are ready to go again. So yes, there's very a chance that within hundreds of years of these events occurring, that you actually start to see a change in the amount of sediment that's actually sitting up in these catchments available to be eroded.
That's great. Thank you for that. We'll have one more question. We'll see what's been upvoted for now, and the rest we'll be able to respond to at a later date if that's okay. So we've got, how was erosion risk post 2019-25s related to fire intensity? If you're able to provide comment on that is.
Yeah, I mean, we haven't looked in that great detail at the results that we obtained. There are three key things that drive variability and erosion risk. The first is sort of the static part of the landscape, if you like, the topography. So the terrain needs to be steep for you to have a lot of erosion. The second part is the rainfall regime. So in the USLE model that we used to map erosion risk in these fires, the rainfall regime is represented through rainfall erosivity, and that varies quite a lot up along the east coast. So for example, up around Port Macquarie in the northern part of New South Wales, you get some tropical influences, so you get a lot of quite intense rainfall when compared to further south. So the rainfall erosivity is a really important driver of erosion risk as well. Fire severity is the third one. So how the relative importance of those three is not something we've looked into across these sort of large regional scales, but it would be a really interesting question to explore further.
Definitely. I'll just have a quick squeeze of what else we had here, and then we'll move on. We'll have one more actually, sorry. So we've got a little bit of, we'll have one more minute for this. So can the risk assessment be used as a preventative approach to support fire planning, and where to conduct controlled burns, apologies?
Yes, I think this sort of information can be really useful to help guide both fire suppression during an incident, if it's burning in areas where you don't have risk to life and other assets, then where do you allocate your resources while you're fighting a fire can be informed through this sort of modeling. And in planned burning, where you target fuel reduction and where you want to modify your fire regime and optimize it in a way where you reduce risk to water quality, is another place where our modeling approaches would be able to provide really useful information.
That's great. Thank you so much for that, and thank you for your wonderful presentation. That was really informative, and we've got a few more questions that have come through that I'll be able to send to you post the event for you to respond to, if that's okay.
Thanks, Janice. Yeah, I'm more than happy to answer questions. Thank you.
Thank you. Next, we have Dr. Phillip Jordan. Sorry, I'll just come back. So Phillip is a principal hydrologist with over 24 years experience. He works at Hydrology Risk Consulting, HARC. The focus of his work is on modelling the impact of bushfires on long-term yields and forested catchments. He was also the project leader for e-water source catchment software, which he's used in multiple projects with his work both here and in New Zealand. He was also a fellow of the Peter Cullen Water and Environment Trust. So Dr. Phillip, if you would like to take over, that would be great.
Great, thank you. I'm assuming you can see my screen?
Yes.
Yes, great, fantastic. So I'm delighted to be here this afternoon to present to you on some work that myself and my colleagues at Sinclair Knight Mertz and then HARC, and then also several associates at the University of Melbourne have undertaken over the years on characterising the hydrological response of runoff from forested catchments to disturbances. So by disturbances, I'm really referring to three main causes of disturbance in forested catchments. The focus of today's talk, which is on bushfires, but that also interacts, and I'll get into this a bit later, with timber harvesting and the influences of climate change. So in outline today, I'm going to talk about the drivers of hydrological response in forested catchments, and that's the classic Kuczera Curve. And then I'm going to talk about three specific case studies. The first one looking at water yield from Melbourne's forested catchments. The second one looking at the long-term changes in water yield following bushfires that occurred in the Murray-Darling Basin in 2003, 2006 and 2009. And then the third case study is looking at changes in the short-term flood risk in the Thomson and Latrobe River catchment. The final area I'll talk about will be recent developments in modelling these sorts of impacts and in future directions. So firstly, drivers of response in forested catchments. About half of Melbourne's forested catchment area is covered by mountain ash forest and other ash species forests. So the remainder mainly being mixed species eucalypt forest or drier eucalypt forest. When the wetter ash forests are burnt by a high severity bushfire, the trees are all typically killed. And so what you get is this sort of response. So the 0 year showing a removal of all of the trees by an intense wildfire and an intense bushfire. After about 5 years, the trees start to come back and you get saplings growing, and they grow up over about a period of 20 to 30 years, which you can see there. After that point, the mountain ash forests or the ash type forests tend to self-thin. So there's a reduction in the number of trees per hectare. And so what happens over time is that there's a change in both the leaf area index and the sapwood area index. And it's that change in leaf area index over time and the change in the amount of sapwood that affects the amount of water that is sucked up through the root system and transpired out of these mountain ash type forests. So what that looks like is described by the Kuczera Curve, which George Kuczera derived back in the mid-1980s. And what that shows, as you can see here, is that there may be a small initial increase or possibly no increase in water yield in those first couple of years. But then as the forest grows back the high density of new saplings causes a net reduction or net change in water yield compared with the mature forest. That peaks at somewhere between 20 and 30 years, but then the self-thinning effect kicks in, and there's a change in the water yield where the water yield gradually increases. And after about 150 years, we get back to a situation where the water yield from that forested catchment is back to its mature long-term state. The important thing to note is that this was derived mainly for ash forests, so reseeding type eucalypts. It was derived post the 1939 bushfires, which caused widespread devastation across Melbourne's water supply catchments. And it was derived using data that George had available to him at the time. So that was pre-fire streamflow data from 26 to 38, and then post-fire streamflow data from 1941 to 1981. Later, Matthew Brookhouse came back and looked at how those curves looked with some additional streamflow data that was collected over a longer period of time. And he found a very similar shape to the response, but with a little bit of an earlier peak, a slightly faster recovery, and a slightly lower peak than what George Kuczera found. You can see, though, that even in George Kuczera's original curves, there's a considerable degree of uncertainty in those water yield curves. Having said that, there's definitely a significant effect. So that peak reduction in water yield of somewhere between 400 and 600 millimetres a year obviously amounts to a significant amount of water across a forested catchment. So moving on to Melbourne's water supply catchments. They've been modelled over the years using a model that was developed by Fred Watson around in the late 90s and early 2000s called Macaque. Macaque's a very detailed model which cuts a forest catchment up into a number of hill slopes. The hill slopes then have many processes modelled, so the rainfall coming in, evapotranspiration coming out from the overstory and the understory canopy, and also directly from the soil. That then accumulates down the hill slope and adds up, once we add up all the hill slopes and we add up all the strips down the hill slope, we can get a derivation of the change in water yield over time. And that Macaque model can then be calibrated against gauge streamflow data. That was looked at in a study called the Wood and Water Study, which was conducted in the first decade of the 2000s. So Paul Fakemer and others derived a Macaque model for the Thomson catchment, and their model, their result, which comes out of Macaque for the change in water yield over time, is shown by the red curve. So we can see there that it's quite similar to the Kuczera Curve. It does show, Macaque model does show that there is a small period of a slight increase in water yield that persists for about 2 or 3 years after bushfire. But then the same sort of peak reduction in yield of about 600 millimetres per year, and then a long and slow recovery back until the forest is about 150 to 250 years old. The Wood and Water Study and the modelling that was done by Paul Fakemer and others also looked at other species. So they were able to look at derivations of the change in water yield for other species types. And you can see that for Delegatensis and regnans, so the ash-type forests, there's a fairly similar response curve. And it's, again, similar in peak to the Kuczera Curve. However, for mixed species eucalypt forests, they found that there was the peak reduction in yield was smaller and the recovery was a bit faster. And again, and the same for silver wattle or for acacia. And the significance of that is that if it depends where the bushfire occurs, and it also affects the water yield can also be affected by what species might come back in place of a severely damaged forested ecosystem. So Paul Fakemer and others then also applied the Macaque model to look at the 2009 bushfire severity. It was limited or affected. The high severity fire was really in the catchments in the northern part. So Wattle and Silver Creeks was virtually completely burnt. There was also a significant area of high severity fire in the O'Shanassy and Maroondah catchments. But in the Upper Yarra, it basically didn't touch the Thomson or Upper Yarra catchments. So the net reduction, projected reduction in streamflow yield across Melbourne's system due to the 2009 bushfire predicted in their study was between 12 and 24 gigalitres per year. My second case study is looking at the Murray-Darling Basin. So Murray-Darling Basin, obviously high importance for irrigated agriculture and human habitation and water supply to Adelaide, and also environmental assets across the Murray-Darling Basin. So water yield is obviously very, very important. It's been subject to really 4 significant bushfires over the last couple of decades. So the 2003 alpine bushfires in Victoria burnt more than 1 million hectares, and that's shown in green. The grey area shows the area of the 2006-07 bushfire, which again burnt just over 1 million hectares. And then the 2009 Black Saturday bushfires burnt about 400,000 hectares, which did straddle the catchments flowing south towards Melbourne, but also the catchments that flow to the north and into the Murray-Darling Basin. And then I don't have it on this map, but obviously the bushfires that occurred over the recent summer affected runoff, affected a significant area of the Murray-Darling Basin. And the significance of that, as I said, is that this is really the highest yielding part of the basin. So if we look at mean annual runoff, all of those dark blue areas were really the areas that were affected by those bushfires. So 2003, rough spatial extent there, 06, 07 there, 2009 there. So based on some work that I did with some colleagues back at SKM several years ago, we looked at, we used a model called BUSY, which is a much simpler computational structure than Macaque, but it represents a lot of those similar structures that you see in a Macaque model, or a lot of those, and also picked up by the Kuczera curve, with that change in water yield over time, which depends on where the fire occurred, the age of the vegetation pre-fire, and the severity of the bushfire. So, for example, for the Dartmouth Dam Catchment, which is one of probably the most significant storage in the southern Murray-Darling Basin, we can see that the BUSY model shows a slight increase in runoff, all those green areas in that first year post-fire. But looking 25 years post-fire, you can see all of the red, pink, orange areas are the areas where the BUSY model was predicting significant reductions in yield across the Dartmouth Dam catchment. So what that looks like when we accumulate it is that the black line is the response that we would have expected had there not been the 2003 bushfire. So a gradual recovery or gradual increase in yield as the forest that was there prior to 2003 continue to mature, get older, and therefore use gradually less and less water. The grey dotted dashed line shows the fire response. And it's really the gap between those two lines and then adding that up over time that adds up to the cumulative yield. So that cumulative yield is, I think my numbers are about 200 gigalitres over time, or about 10% of what we would consider sort of a current estimate of water yield into Dartmouth Dam. My third case study is really looking at the changing short-term flood risk in the lower Thomson and Latrobe rivers. So in the lower Thomson flood study, we had a RORB model, which is commonly used for flood estimation for the Thomson and Latrobe rivers. That was calibrated to a large number of stream flow gauges across the catchment, and then that was fed into a two-flow model to model the hydraulic impacts or the flood impacts in the lower part of the Thomson River. As a sensitivity run, there was a run done where a bushfire was basically imposed on the forested parts of the catchment. And that bushfire was assumed to have a reduction effect on the initial loss and continuing loss from the catchment. So that scenario, these are the changes in the 1% or the 1 in 100 year design flood estimate at each of the major stream flow gauges, which were used to represent inflows to our hydraulic model, which was the bottom part of the system. And you can see that the increases are very significant. So looking at increases of somewhere between 23 and 67%, with an increase by the time you get down to Lake Wellington at the bottom of the system of 47%. So those are quite large numbers. It is important, though, in a risk context, to point out that those increases really only persist for that first 2 or 3 years post the bushfire. So now I'm going to talk a bit about recent developments and future challenges in this space. The first one, and these are really based on a lot of research that's occurred in recent years. The first one is around the use of alternative means for modelling water yield impacts. So the Macaque and the BUSY models that I mentioned earlier chiefly used leaf area index as the predictor of the change in evapotranspiration from eucalypt forests. Recent research that Dominic Deskerniak and Richard Benyon and others have undertaken has found that sapwood area index can be a much better predictor, and that can be estimated using LiDAR data. So that's offering a lot of promise in terms of an alternative means of modelling, eventually of modelling evapotranspiration and therefore water yield from forested catchments. The second one is really around the response of mixed species eucalypt forests. So the Kuczera Curve's been around obviously for a long time, several decades now, but it was derived in Melbourne's wetter forested catchments that were largely ash-type forests. Trying to extrapolate that curve to mixed species eucalypt forests is a bit of a challenge, and there's been more recent research that's looked at long-term age studies, paired catchment studies, to try and get a better handle on what the shape of that curve looks like in mixed species eucalypt forests. The third area, again, this is work that was undertaken at University of Melbourne, is improved algorithms for spatially interpolating precipitation. And that's really about trying to understand, when we've got a bias in where the rainfall gauges are located in the catchment, what does the spatial definition of, what's the spatial pattern of precipitation across the catchment? And that's important for trying to understand how well our model is doing at estimating the evapotranspiration component, which is the difference ultimately between the precipitation and the runoff. So trying to understand how accurately we're modelling evapotranspiration, it's important to understand, well, what is the precipitation going in, and hence what's the difference between that and runoff. The last one's really important, and this is the recognition of the potential for transitions in forest types or forest structures. So the ash-type forests are reseeding eucalypts, and if they get burnt more than twice within a period of about 20 years, there's a loss of the seed bank. If the seed bank isn't artificially replaced, then those ash forests can't reseed. So where we're getting these repeated bushfires over the same terrain, which we have seen in parts of southeastern Australia over the last couple of decades, those wet sclerophyll, those ash forests can't regenerate themselves. And in that situation, we might well see them replaced by other species, such as wattle, acacia type shrublands. If that occurs, there's sort of some interesting, there's obviously a loss of biodiversity and habitat values in that transition. But the weird thing is that from a water yield perspective, it might actually increase the water yield over the long term, because the acacia shrubs don't use as much water typically as a ash type forest. So the important thing to note there is that there's really these three elements that interplay. There are the bushfires, there's climate variability and climate change, which is a significant factor in southeastern Australia, or in all of southern Australia over the last couple of decades. And the last one is timber harvesting, which does occur across many parts of forested catchments in Australia. And all of these interact. So if we look at annual inflows to Melbourne's major dams, the long-term average is shown as the top dashed line there. The reduction, we've seen about an 11% reduction in rainfall since 1997 over Melbourne's water supply catchments. That's translated into about a 30% reduction in mean annual inflow to the dams. And that's caused by some unknown or difficult to tease out interaction between the three factors. So a lot of it is probably caused by that climate variability and climate change component, but there could well be significant interactions with timber harvesting and bushfires, and how those interplay in the future is going to be really important, which is really where my next slide goes. So we've got these factors interplaying on the left-hand side that impact the water yield, and as Ped has pointed out, they impact on the water quality. That then goes into a reservoir and water supply system, which is subject to demands. Those demands are then affected by themselves by climate variability and climate change, by population growth, and also whatever we do around the demand management side, and trying to think about water use in cities as an integrated water management problem with other options to try and augment supply. And the system's also augmented with desalination inputs now. So all of those things have an influence on the security of supply and the water yield. And in my view, in future, we really need to be looking at how that integrated system works together. So future directions, I think there's certainly ways to go around improving models to incorporate new science and data sources. It's important to assess that four bottom line outcome for water supply around economic, social, environmental and cultural impacts, and trying to estimate to incorporate these things in stochastic models. So dealing with all of those uncertainties and interactions between drivers is going to be increasingly important in future. And that's the end of my talk. Thank you.
Thanks, Philip, for that. That was a really great presentation as well, and we really appreciate you sharing all your knowledge and research of late. So we have a few questions that have come through. We can start with maybe the one that has been upvoted. So Jasmine has got, how would you see the impact of the climate change, a drying climate, on recovery of yield in the long term post-fire?
It's going to vary a lot depending on what catchment you're in and what's going on. So I think it's fair to say that the previous modelling that's been undertaken with Macaque and with Busy is still a reasonable guide to what is likely to happen in terms of the change in water yield over time. But I think it would certainly be good to invest in some models that more explicitly deal with those uncertainties and more explicitly deal with the interactions, as I've said, between climate change, climate variability, recovery of vegetation, and possibly changes in forest structure. So changes in looking at the likelihood that different types of forests might come back to replace what was there before.
Thank you for that. We've got another question here from Charlie. He's asked, can you comment on the difference in results between post-fire yield in mixed forests between Fakima's 2006 study and the much lower impact from more recent studies by Nolan and Turnbull in mixed forests that suggest close to no yield impact in mixed forest?
I can't comment specifically. I think I would agree that the more recent research is showing that the mixed species forests there probably is less impact and the recovery is faster than what the Fakema et al. Modelling would have shown. Across Melbourne's catchments, yeah, I think that's probably all I'll say is that it would be good to go back and revisit that, and I think the more recent experimental work is showing different results.
Yep, no worries. Thank you so much for that. Our next upvoted question is from Fiona about groundwater extraction occurs in a big way in the Thomson River catchment. Is this considered or is it still a small input?
Yeah, it's not explicitly considered in the Macaque model, and yeah, so I'd actually need to go back and check to work out how it was considered, if at all. Yep. The Macaque model is really was mainly used to look at the incremental changes in water yield under a bunch of different scenarios. So it wasn't necessarily used to look at the absolute water yield. It was more to look at if there are changes, for example, in logging scenarios, or if there are future bushfires. What are the outcomes from those? What are the relative outcomes from those different scenarios in terms of runoff changes?
Okay. Thank you for that. Hopefully that's answering everyone's questions, and anything that that you need to take on notice, we can answer later down the track as well. We've got time for one more question before we move on. So we've got Chris has come in here with, are there any plans to conduct some analysis and run these models post 2019 fires in the Murray-Darling Basin?
Well, I think there should be, but I'm not aware of any at the moment.
Yep, no worries. Well, thank you so much, Phillip, for your presentation and sharing your experiences. That's been really helpful and informative. And for everyone listening, we will be following up any remainder questions post the event and sending that out with the recording. So we will aim to achieve answering all of yours that you have during the event. All right. Now we will move to Rachael Brownstein. So she is a Treatment and Environment Officer at East Gippsland Water. She's responsible for the management of East Gippsland Water's drinking water quality risk management system. So if you can share your screen now, Rachael, that would be great.
Hello everyone. So my name's Rachael Brownstein. I'm from East Gippsland Water, and I'm presenting today on what we did to supply drinking water during and after the East Gippsland bushfires. So the photo here that I've got at this first slide is from the Nicholson River, and as you can see, so we don't extract from the Nicholson River, but it just represents the extent of the damage that happened during these bushfires. And what I'll be talking about is what the challenges we faced during this time, during the bushfires as well as after the bushfires. Just a little bit about East Gippsland Water. We supply drinking water and wastewater services to East Gippsland over 21,000 kilometres squared area. So it's quite a large area. It's from Bairnsdale as far as Mallacoota and as high as Dinner Plain. And we have 25,400 customers to date within that area. Just take a picture in your head of this map, because I'm going to be talking about the extent of the bushfires, but I just wanted to point out that this area is extensive, and it's actually 3 hours from our head office in Bairnsdale to Mallacoota, which is, we've got an office in Mallacoota, an office in Orbost and an office in Omeo. So we're the ones who when you turn on the tap out here, we're the ones supplying the drinking water, and we're dealing with it when you flush in the toilet as well. So, East Gippsland bushfires, pre-COVID-19. There was the East Gippsland bushfires. These actually started in November 2019 and progressively got worse over the period of time of December and January. Actually, on the 21st of December, before Christmas, Omeo and Swifts Creek were actually inaccessible because of the threat of fire. And then on the Sunday, the 29th of December, the entire of East Gippsland was sent this message to say, get out. The worst case scenario could happen on Monday, the 30th of December. Come Monday, the 30th of December, as you can see, the majority of East Gippsland was under a red warning sign. The fires, the worst case scenario did happen. And then, as you can see in the bottom right-hand side, the extent of the fires was unprecedented. It was extensive. Over 1 million hectares of land was impacted by these fires. And if you recall that map I showed you before, it very much overlapped with our serviced area. I also wanted to emphasise the intensity of these bushfires. This is the picture from Bairnsdale, the township of Bairnsdale, on the evening of the 30th of December 2019. And as you can see, only an intense fire is going to cause a vision like this. It was like Armageddon with the black clouds and the red hues threatening the township of Bairnsdale. And as you can see on the right, the burn severity overall, which was mapped at the end of January, outlines just how severe this fire was. Quite a lot of that is in the most severe area. I wanted to talk to you a bit about what we had to do in a couple of our sites, in particular Mallacoota. And then I'll go on to talk about the change in water quality that we saw in our rivers. So just to note, we actually we extract water from rivers, and a couple of areas we rely on boil water. We don't have any big storage reservoirs. And I guess I also wanted to point out that we do have preparedness for this type of thing. So we have to be ready for fires. So we do have sprinkler systems on our water treatment plants, and we do have bushfire preparedness that we practice and make sure is up and running before summer period hits. I'd also like to point out that to manage this incident, we actually set up an emergency management team. So we have an emergency management response system at East Gippsland Water, and we actually initiated this emergency response team and emergency incident control centre to make sure that the way that we managed the East Gippsland bushfires was coordinated, and to make sure that we were liaising very closely with DELP and the emergency services at the time. We actually had 31 people involved over 36 days in this incident control centre, which is quite a significant proportion of our staff. We've actually got only about over 100 staff, and so a lot of staff time and dedication was put into managing this incident. So first up was Macaque. If you can recall, Macaque was under ember attack on the 31st of December, and actually saw quite a few houses burned down. And one of the biggest challenges we had to face at the time was managing the demand that we were facing for our water. So as you can imagine, we had many of our customers trying to save their properties, trying to put out the fires, and obviously relying on water to do that. And we had to make a decision of what service was it that we were to provide for our customers. If we wanted to keep up with demand, we might have to change our operations, which might mean that we might not have the deliver water that was treated to the full Australian drinking water standards, or ensure that we could treat the water, but knowing that that water might run out for our customers. And as a result, we made the decision that we would go towards making sure that we could ensure the supply of water for the Macaque customers, and we were very set in that decision. So what we had to do at Macaque was actually bypass the secondary disinfection at our water treatment plant, which led to us issuing a boil water alert for the township, asking everyone to boil water before they actually drank or consumed the water. What happened there was that, as you can imagine, with a town under threat of fire, one of the biggest challenges for the boil water alert was the communication. So you can't do a door knock and you can't drop letters in. How could we do that? Well, the way that we came around that was through communicating through the Vic emergency app, SMS, the radio, all these other forms of communication to get that boil water alert out. One of the other challenges that we faced was Macaque was cut off for quite some time, and we had only three people out at Macaque, working away to not only deliver the services to our customers, but also to protect their own properties and also to help their friends and family and be there as well. So we acknowledged that there was quite a lot of fatigue and stress on these people. And so we had to actually helicopter resources into Macaque to help them out. And that also had to be done to ensure that we were sampling our systems as well. So we have to follow a drinking water sampling program, and we had to make sure that was happening. So we actually helicoptered in people to go and sample the system as well. The bottom left picture here on this slide, whilst we were very lucky in that the sprinkler system worked effectively to protect our water treatment plant and ensure that we could provide services, this is the damage that did incur at Macaque, and this is a raw water cover. So we cover this raw water storage to prevent algal growth and to kind of manage some of the water quality risks. But as you can see, that was impacted by ember attack, and we're still working through fixing that at the moment, actually. So this type of thing that happened at Macaque wasn't unique to Macaque itself. A similar thing happened at Buchan, we had to issue a do not drink notice for Buchan because we had run low of tanks and thought we might have to supply raw water straight to town just to make demand. And Omeo, that did happen as well. So we actually had to bypass the whole water treatment plant at Omeo and deliver raw water to town just to ensure that they had enough water to be able to put out those fires. So this is all during the event, but I guess as Petter and Phillip has mentioned, then came the rain. And I guess I'm about to tell you what happened on ground in East Gippsland after the rain came through these fires. So this is the Brodribb River on the top left. It became very brown, as did the Buchan River. That's quite ashy water there. The turbidity increased significantly. And we were aware of this during the time of the incident, so we were prepared to know that this would happen. So I guess I just wanted to point out that it did happen. And we had a few management techniques in place to manage the increased turbidity and to make sure that we could treat the water to safe drinking water quality standards. So these are just some of the things that we had to do. At Dinner Plain and Mallacoota, we extract from bore water anyway, but Mallacoota we have the option of extracting from bore water or river water. We relied on bore water to manage this risk, and that's proved effective there. The bore water wasn't impacted as much as a surface water would be. We've also been relying on selective harvesting and reliance on our raw water basins. So when the turbidity gets too high, we stop taking water out of the river and rely on the storage of that raw water in a raw water basin. So that was one other strategy that we used for change water quality. In Orbost, it was acknowledged that the turbidity was so high that such an approach wouldn't be able to work for us. So we actually had to set up additional treatment to the whole system, including, so we ended up having to put 4 silt busters in. So silt busters ultimately help in removing that sediment that was coming down the Brodribb River, which is in the picture that I showed you before. This required extensive amount of staff time. We had 24-hour standby, someone on site for 24 hours at a time, and really had to manage our fatigue around that. But we've since automated that process, and that's still happening there. And again, that has proved very effective in helping our water treatment process. We're managing to supply 100% compliant safe drinking water to Orbost, Marlow and Numaralla. That's where that one services. Buchan, as I mentioned before, was also very much affected by changed water quality, and in the build-up of getting a silt buster automated, we actually had to rely on water carting, so taking treated water from a different system and then putting it into the Buchan water treatment plant. So amongst this, I actually wanted to also share some of the personal challenges that I had and also what represents other staff and those people of East Gippsland. So during the bushfires, this is the view from the back of my house on the 22nd of the 12th, 2019. And this was before Christmas, obviously. Our decision was to leave, and come the 30th of 12th, that turned out to be a very good idea, because as you can see, the fire got very close to our property. At one point, we thought our house actually had burnt down. So we actually had to stay in Bairnsdale with the friends and the dog and the chickens. And it was quite an unsettling time for us, in that not only were we dealing with it at work, but also, wondering what's happening at home. My partner was also on the front line fighting fires. He works for DELP. So that was, that was scary as well. But I guess I wanted to point out that I was grateful to be involved in this emergency incident, because it made me feel like I was contributing. At these times, in these situations, you don't know what to do with yourself, so feeling like you're helping in some way really helped me along to survive and to keep busy, I suppose. So in summary, East Gippsland Water can proudly say that despite the bushfire event, with staff, homes and properties under threat, and some of our staff did lose properties, we were able to maintain sufficient supply of water to our customers during such an intense incident. We took measures to protect public health and have since been providing safe drinking water to East Gippsland despite the rapidly changed rural water quality. And I think that just shows how much work East Gippsland Water staff and East Gippsland itself has had to deal with over this time. So that's my presentation. Thank you.
Hi Janice, unfortunately it seems that your mute or your microphone isn't working.
Oh, can you hear me now?
Yes, we can, thank you.
Oh, sorry, so I was just talking to myself. Thank you, Rachel, for that presentation. That was really informative as well, and I really appreciated your personal challenges that you were describing. I thought that was, yeah, it would have been a very tough situation to get through. So we do have a question in here. I have from Rhiannon. Did you implement any catchment interventions like the koi logs post-fire to mitigate the potential water quality risks?
Yeah, so we actually looked into that and tried to see if what Melbourne Water had done could work for us. I think the issue with East Gippsland bushfire was that it was so big and there were so many areas impacted to know where to, yeah, it was just almost a bit too hard to deal with it. And we kind of acknowledged that by the time, you know, that could have happened, it might have been too late. So we did think of it, but we just decided that in this situation, it wouldn't have been as effective. So we didn't go down that path, but it was something we definitely looked into. Yeah.
Thank you for that. So Genevieve has also written in and asked, sounds pretty tough. Can you explain a bit more about how the silt busters work?
Yeah, okay. So the silt busters work by pretty much the water comes, gets sucked out of the raw water basin, goes through the silt busters, and it's kind of like clarification. So it goes through the system and it captures the sediment in the silt buster. I could probably show a diagram to, you know, if someone wants more information on it. But ultimately, that silt gets captured through the use of other chemicals and gets put into a bag and gets taken off site. So that sediment is completely removed out of the system through that situation.
Great, thank you for that. I also had a question as well, as we've still got some more coming through slowly. I wanted to ask you about, have you sort of got a bit more of an idea around the economic impacts to your operations post the fire?
I don't have the exact stats for that, but I might be able to share it. I'll have to check. But yes, it certainly put a few spanner in the works for what we were planning to do this year, particularly with that raw water basin cover. That wasn't originally a project that was on the list, but I think I can follow that up just to see what's happened there. Yeah.
Thank you. We've had another question come through from Fiona. Can you provide comment on how closely East Gippsland Water works with the CMA and DELP forest fire management in the lead up to bushfire seasons and in fuel reduction processes? How are all agencies of water supply catchments versus other forested lands?
Yeah.
I think it's how we're.
Is this in regards to the build up to bushfires? So I think.
Yep.
So we do have a staff member who does liaise very closely with DELP because he works in risk management. So that overlaps into kind of a different area, and he works closely with DELP and what's happening there. In terms of the CMA, we did have close conversations with them over this period of time to see, you know, what were they seeing upstream, and to make sure that we were understanding the risks to our drinking water. So we did closely liaise with them, and we continue to do so post-recovery, post-fire in the recovery stage, to make sure that, you know, our risks and the things that we need to be addressed are being thought of at the time as well.
Great. Thank you so much for that, Rachel. That was really appreciated. That was a really great presentation. I think we've answered most of the questions as they've come through. I was just going to add one last slide. I'm just waiting for it to come up. So I want to thank all of our speakers for coming and presenting today. That was greatly appreciated and very informative, and I'm sure we'll have a few more questions to send through your way for response. So we appreciate your time in coming today. I would also just like to let everyone know that's still on the line that one of our next upcoming events webinars will be on water markets and transparency. This is going to be held on Thursday, June the 4th at the same time for a lunchtime Zoom. And will include presentations from Dr. Erin O'Donnell from the University of Melbourne and Ben Williams from the Australian Water Brokers Association. And I will be joined by Chris Olzak from 8th Economics and Jeremy Cheeseman from Jacobs in a Q&A panel discussion. So I just wanted to thank everyone again for coming to the webinar today. I think it's been a really great session and we look forward to hosting more in the future. And thank you again to all our panel speakers today as well. It was, yeah, it was very great to sort of understand a bit more about the impacts on the water quality and the yields post the current events and previous events and how that's impacting future management. So with that, we'll be ending the session.